Hey, it's Tim the Tutor here with Free Test Prep Online, and in this video I bring you the Organic Chemistry one-slide guide to conjugation. Conjugation refers to a molecular system that has three or more overlapping p orbitals. For p orbitals to be overlapping, they have to be on adjacent atoms and must be oriented in the same direction. An atom has a p orbital if it is either sp2 or sp hybridized. In a molecule, an atom that has a p orbital can be identified in the following ways. 1. The atom has a pi bond. 2. The atom is a carbocation. 3. The atom has an unpaired electron, also known as a radical. Or 4. The atom has a lone pair and is adjacent to another atom that has a p orbital. Now this can use some further description. So for an atom that has both a pi bond and a lone pair, we already know there's a p orbital because there's a pi bond. So the atom's sp2 hybridized and has a p orbital. However, the lone pair itself is not found in the p orbital because the electrons in the pi bond are found in the p orbital. So the lone pair is found in the hybrid sp2 orbital. However, for an atom that does not have a pi bond but has lone pairs, one of the lone pairs is found in the p orbital if and only if an adjacent atom also has a p orbital. Now, just as a general note, if a molecule is conjugated, it will have resonance structures. The molecule will also be lower overall in energy than similar non-conjugated molecules due to the resonance stabilization. So let's take a look at these 5 examples and see which of these are conjugated and which ones are not conjugated. So we're going to start with propadiene. We see the central carbon is double bonded to 2 other carbons. It looks like all of those carbons have p orbitals because each of those carbons does have a pi bond. However, you have to remember that for p orbitals to be overlapping, they have to be on adjacent atoms and must be oriented in the same direction. If we actually look at the p orbital view of propadiene, we can see that it's not conjugated because the pi bonds have p orbitals oriented perpendicular to each other. Now, when we look at buta-1,3-diene, this is conjugated. So we have a pi bond separated by a sigma bond and then another pi bond. And this is your textbook case of conjugation. If we look at the p orbital view here, we can see that we have 4 overlapping p orbitals. In penta-1,4-diene, however, notice that there is a carbon between the 2 double bonds. If we look at the p orbital view, we can see that it's non-conjugated because the p orbitals are separated by that central carbon that is sp3 hybridized. Therefore, that middle carbon does not have a p orbital. The next molecule over has a double bond, and adjacent to it is a carbocation. That's what that plus sign is. This is also conjugated. That's because carbocations have an empty p orbital. The p orbital still exists even though there aren't electrons in it. So this qualifies as having 3 overlapping p orbitals. And finally, we have a negative charged carbon, so there must be a lone pair on it, and that's adjacent to a double bond. So if we follow our rules, we do have a lone pair adjacent to an atom with a p orbital. That must mean that this is also conjugated. You can see in the p orbital view that we do have the lone pair occupying that p orbital. If you got something out of this lecture, please feel free to like this video and subscribe to this channel. If you have any questions or comments, leave a message below. And last but not least, if you want more help or want easy access to valuable organic chemistry resources for free, be sure to check out the notes underneath this video with a link to join our community.